And now the continuation of Safe by Design.
Looked at some of the technology that was there, kind of some cool stuff that we could use to solve the problems on the machine. But we noticed that there's going to be some manual involvement as far as operators actually using the machine, and there's going to be hazards associated with those operators doing those actions, right? So I have asked our local safety expert, Kevin York, to come in and talk to me about how we can make sure that we're protecting our valuable resources, our operators, and make sure that they don't get hurt in the inspection process of this machine. So Kevin, thanks for coming in today. I appreciate it.
Good seeing you again, Hayden.
Awesome, awesome. So tell me a little bit about how we can apply safety to this inspection machine that we're getting ready to build and all that good stuff.
Yeah, so that's a good topic to cover, Hayden. We definitely want to be concerned with safety of our employees. Kind of the first getting started, have you done a risk assessment on it? Or what's your risk assessment look like?
What's a risk assessment?
You sound like most of the other customers we talk to. Yeah. It's a good topic for us to cover.
All right, so risk assessment, huh?
Yeah.
Tell me about that.
So a risk assessment, just a general kind of overview of what a risk assessment is, gives you a way to go in and evaluate your machine, looking at it, rank the hazards on your machine, also look at it from everybody that interfaces with the machine. So whether it's operators, engineering, maintenance staff, cleaning personnel, anybody, you really want to look at it from all of their eyes and just rank anything that they interface with on the machine. So, and when I say rank it, we want to quantify that so that we can design our safety circuit to meet and protect that person adequately. Again, so like I said, this is just kind of a looking at the risk graph here. When you're looking at it from a basic risk assessment.
Real quick, so what you're telling me here is that for every task that, say, an operator does on the inspection station, we have to evaluate each one of those tasks?
Pretty much. And that documentation covers you in case there ever is an accident, also shows that you've done your due diligence.
So including the maintenance people, anybody that basically comes in contact with the machine, every task they do, we have to basically look at that hazard.
That's correct. In your case, you're lucky, but we've had a lot of customers even that have wash down personnel, cleaning people come in, they have to evaluate it for them because a lot of times that's people that get hurt because they're not properly trained on this type of equipment.
Wow, okay, all right. So we've got structure category over here, and then it looks like PL is?
Yeah, so looking at this chart here, basically if you look at the structure category, those that's been involved in safety for years, we had categories. You saw they were there, you had a 2, 3, and 4 category safety systems.
Yeah, I remember those, sure.
So that has kind of moved over into performance levels now.
Okay.
And that's what this PL stands for. Performance levels really take into account the probability of something happening or a mean time to dangerous failure of your components.
So the category didn't take that into consideration, but the performance level does.
That's correct.
Gotcha.
The category portion is still a portion of your evaluation, still utilized and talked about, but really everybody kind of talks about performance levels now.
Okay. All right.
So, and again, you can see here our performance levels, how they correlate to what our risk level is on our machinery. And also, when you start looking at, like I said, the categories, is still how they kind of translate to what our performance levels are.
Okay, so there's some parallel mapping there that we can actually do.
Especially when you start looking at it from the standards.
All right, Kevin, well, this looks kind of complicated, maybe a little bit of work, but take me through just a quick step-by-step on a risk assessment.
Yeah, it's really not that complicated, Hayden. It's more of a documentation procedure. Chances are you've done a risk assessment and just didn't document it in the past on your machinery when you're evaluating some of the hazards. But really, you kind of want to start with determining the limits of your machine, how fast it operates, how frequent it's running, how frequent that operator interfaces with the hazard or the piece of equipment. And then we want to lay out kind of our hazard identification. What's the pinch points? What's our entanglement areas? Things of that nature. Okay. And then we want to rank them based on that chart we recently saw and give it an estimation and then evaluate the risk. Basically, we'll go in and put what guards we want to put in place or light curtains of that nature and then reevaluate the machine once we've done that to be sure our remediation process is taking care of the hazard.
Nice. That sounds like it's pretty critical to do the remediation part of that, right? So we're not done just by applying. We got to go back and make sure that it actually works.
Yeah, initially, like I said, you evaluate the machine with no guards in place. The machine is what it is, and that's where kind of, if you're in the design phase, you may have the opportunity to design the hazard out totally. You may choose to incorporate that robot. It may pay for itself based on what you're trying to do. Again, a lot of times safety is dealt with after the fact, so it's a little bit more of a challenge to deal with then, and you also kind of stuck with what you got. If you can design it out in the beginning, obviously you're a lot better off.
Awesome, awesome. Okay, and then you make the evaluation. If it looks like the operator can operate the system safely for that particular hazard, then we go and move on to the next part.
That's correct.
Awesome. Okay, cool.
The
Whoa, wow. Oh, but hold on here. Do I have to do a risk assessment?
You are lucky. The standards now tell you that you have to do a risk assessment.
I have to do a risk assessment. This is not optional anymore.
Nope, it is not optional. So again, more and more of the standards are calling out a risk assessment. So if you're following the safety standards, you really should do a risk assessment and have it documented in your process there.
A risk assessment shall be performed and is no longer optional under the RIA standard there. So yeah, that looks like I got to do it, right?
Yep, it's no longer optional. I was talking to a counterpart, the 2023 standards now that just came out, it's called out, risk assessments labeled 200 times in those standards, so they reference it pretty frequently. And it's not just on the end user anymore, it's on the machine builder side, the integrator side, really kind of everybody.
Okay, yeah, so that's kind of interesting too, because you got the OEMs and, like for instance, I want to bring this machine in, but the guy that I'm going to hire to build it for me, is he responsible for it, or am I responsible for it, or who's responsible for really doing the risk assessment?
Really everybody anymore.
Okay, all right, so just because a company comes in and says that the OEM has said that they have done a risk assessment with the machine, then I need to come in and make sure that the risk assessment is right, and if it's not, I probably need to do it myself.
That's right.
Okay, interesting, all right.
All right, SISTEMA. We got a cool tool to kind of help you do with this risk assessment.
What is SISTEMA?
You don't know what SISTEMA is, Hayden?
I have no idea what SISTEMA is.
It's a good possibility. You probably never heard of SISTEMA unless you were shipping equipment overseas, in that nature. So SISTEMA is a tool to really kind of validate your performance levels. Basically that our machine and our system meets the required performance levels that we're saying it does. So again, it takes into account that mean time to dangerous failure. All that information has that in the tool and can validate our system once we put it together and give us the documentation back that we can supply to the end customer saying we did our due diligence, or the end customer can do it themselves. So again, if you were shipping equipment overseas, you historically had to do this anyway.
And so when I'm done doing the evaluation within SISTEMA, what does that give me? What do I have then at that point?
You've got a document, probably depending on how large your machine is, it could be a 20 or 50 or 100 page document that you can hand to the lawyers if there ever is an accident, showing you did your due diligence, how that machine was designed, that your system basically adequately meets the performance levels that we did in evaluating our risk assessment.
Interesting. Okay. All right. So, but we still got to do a risk assessment, right?
That's correct.
So,
but Rockwell has redesigned a tool as a safety automation builder that can really help you in documenting this process, make your life a lot easier.
So we have a tool that's going to basically walk me through a risk assessment?
You do. And best of all, it's free.
Whoa, come on. Rockwell doesn't give anything away, man.
But just for you and the customers in the room, Hayden, it's free.
It's free. All right. Well, how do I get it, Kevin? How do I get Safety Automation Builder?
So we can get you a copy of it, or you can download it right off of Rockwell's website. It's very, very easy to download and get to. Chances are you may already have it if you're using Integrated Architecture Builder or Proposal Works tools. Okay. It's part of their product selection toolbox.
Product selection toolbox. I think it's an annoying thing that wants to do the product updater every time I power up my computer.
You got it.
I got it. I think I got it.
You may even see it during this presentation.
Oh, exactly. Exactly. All right. So we're going to look at the machine design here. If I remember correctly, we've got a weigh station, and it looks like we're going to have to, the operator would take the plate off the weigh station and put it on the conveyor, right? At that point, the trolley would move forward. So there is definitely a hazard there, right? With the operator potentially getting their fingers or their hand or their wrist involved there. And then we have this nice little car wash cleaning brush right here that's going to clean the contaminant off of the plate, right? And so potentially there's another hazard right there. So instead of going through and evaluating all of the hazards on the machine, we're going to specifically step through a risk assessment for those 2 hazards. Kevin?
Yes. So, as I mentioned, Hayden, this is a look at Safety Automation Builder when we first open it up. Like I said, we'll kind of walk you through the process. We'll do a kind of a mock risk assessment on your machine based on our design engineer's fabulous drawing here that he developed quickly. And just kind of show you how the process works from, like I said, maybe make the task not seem so daunting when you're looking at it. So when you first fire up Safety Automation Builder, you can see here, you can add just basic information in here, what your project name is, some description of the machine, if you got a customer name, potentially like that, if it's your machine builder. One of the other things you can start populating is some of your machine limits that we talked about initially in the risk assessment process that you want to define. The more information we can put in here, as you can see, I've pre-populated it with just operating modes, automatic, manual, intended use, part inspection, and expected users. We got our operator, maintenance, engineering type stuff. The more information we can put in here, the more it's going to help us on the back end from our documentation purposes. Because really that's kind of the big portion of your risk assessment is developing that documentation. So again, the more time we spend on the front end, the more it's going to benefit us on the back end. So once we start looking at the process within Safety Automation Builder, we can really start anywhere in the process, but we want to start with identifying our task. So that's kind of where it's going to start us at over here on this side. And if you got any questions, you'll notice we just hover over it and it tells you kind of basically what's going on or where at in the process you are. So when we look at the risk scoring systems, the previous chart that I showed was kind of based on the robotics industry standard, the 15306 standard. There's another standard that's out there that's commonly used as your HRN system. So depending on your facility, you may be using a different standard. So they've really kind of built where you can use either one into the software to make it easier.
Let's just say my company doesn't have a standard or whatever the case may be. How do I know which standard really am I supposed to use? But the RIA, if I'll get it out, RIA or HRN standard.
So one of the kind of cool things Rockwell's done within the help functionality of the software itself is give you tips on kind of which one you want to look at or just make it easy to answer the question. So looking at the RIA example, you can kind of see here, they give you a graphical approach basically that we'll go through and be able to rank our hazards. And once we get over to the risk level, it will tell us what category performance level we need to meet with our safety system. So again, it works really well for more simplistic type machines. It's pretty cut and dry when you're looking at it all the way through. Based on the standards, they give you the definitions of what each one of these means. So there's really no interpretation on your part, what you want to do for that standpoint. All right. And then when you look over at the HRN example, it's more of a granular approach.
Yeah,
so
maybe they're actually calling out hazards here. Okay, possible to go. I see. All right.
So basically the HRN difference is we'll take these numbers, we'll multiply them all together, and that'll give us a number at the end. And basically that's how we rank our safety system. So there's a direct correlation there from the standards.
So it sounds like the HRN may be a little bit more strenuous, maybe?
It's really, again, depending on what you're wanting to do with your machine. If you're wanting to get more granular in it, maybe you got some different type hazards and things like that you need to rank, the HRN is probably a better example. Okay. From a more simplistic approach, the RIA is definitely a good standard.
Okay.
It's been pretty widely adopted as well.
Okay.
So going back to the software here, we'll use the RIA example just for our example we'll walk through today. The other thing that they can do within the software is you can designate if your facility has a default. Say everything in my facility has to meet a performance level D or above. We can designate that here in the beginning of the process. So if we've got a minimum standard, basically then it won't allow me to build anything below that when I'm doing it. So we'll pick a performance level D just because that is a pretty common ranking. So then once we start getting into the software, we can start designating who the affected people are for our machinery. So you can see here, we've got a list of the basic personnel that would encounter a machine, but you can also add in custom roles. So if you need to add in something more customized to your machine when we're looking at it, for our example, we'll just kind of do it with an operator. And then we can start looking at the tasks that that operator may encounter. So you mentioned there was probably a pinch point.
Yeah, definitely a pinch point when you were putting the plate down onto the trolley there at the end feet of the machine.
So if we select our operator there, what's something that's probably he's going to be doing where he would encounter that? Maybe manually loading?
Yeah,
unloading?
definitely. It's a loading operation for sure. Sure, and there'll be the same thing for the unload, but I know we're only talking about this. So
then we can define that task per that operator.
Okay.
But as you can see, it's a pretty comprehensive list, or if we need to add our own, we have that functionality as well to do that. So once we do that, we can start adding the hazards that he would encounter while he's manually loading or unloading. So you've already mentioned the pinch point, which would be a mechanical, which is probably I think because we're using a servo, we got an approach from moving element to a fixed part.
Okay, all right.
We'll go with that. So we can select that. We can label it. Go ahead and label that. So and then also we want to add, you mentioned the brush. So that's probably
so we
rotating.
got the brush that's rotating where they could get their hands potentially in there.
So we got rotating elements here.
Got it.
So we'll add that up. Still got a selector. All right.
Okay.
So we've defined our hazards now. But again, you would have to go through and do this for every personnel.
For every hazard.
And for every hazard
Okay.
they would encounter. So in the essence of time, we'll stop there with this
Okay.
process. And just kind of show you walking on through it.
Gotcha.
So you can see it loaded us our hazards over here in our layout view. But what we can do is we can incorporate a drawing of our machinery. So as you can see,
Nice. Look at that.
and then this will incorporate our image on the back end when we export all this documentation out of here for you. Okay. The other thing I can do is I can put my hazards directly on my machine and label them that way. So when I go in and actually look at the process, again,
You're going to know where the hazards are on the machine. Okay, that's pretty cool.
And if I have a specific image, we can upload those particular images of that particular part of the machine. Okay. So again, when I hand this over to the lawyers, if something ever happens, I've got it all documented from that standpoint.
Okay. All right, cool.
Now going back to our kind of hazards, we have to rank kind of what the consequences of each hazard are. And this, again, is part of our risk assessment process. So when I start looking at that approach of that moving element or that slide, based on this list of kind of things that's pretty commonly to happen there, is there anything you could see that maybe...
Definitely crushing. Could definitely see crushing being a consequence there. Probably the most.
I think that would be a good choice there. And then we had to do it for our brush as well. So we mentioned it's a rotating brush.
So entanglement seems like, yeah, definitely impact. Yep. So
I think that'd be a good choice.
Yep.
It's almost like you've done one of these.
Maybe. I don't know. No, never. I've never done this.
All right. So once we've kind of developed that, then we can go over to the next part of the process and actually start into the scoring process of each one of these hazards. So,
ooh, here we go.
Here's your chart that we showed earlier.
Yep, I see
where
it
we get
now.
to rank these.
This is where it's showing up. All right, so it looks like we got severity of injury, the first thing that we're going to do.
That's correct. So again, if I don't know what these are when I start looking at my rankings here, or my choices, if I click on the right thing, it pops up my choices. But if I don't know that per the standard, I can click on this little help file here and it brings up the actual link directly to the standard and what each one of these definitions means.
So let's look at that for a second so we can actually know the definition for each one of those ratings. So I don't think we're going to have any fatality, probably not amputation long-term, anything like that. So broken bone, definitely. Severe laceration, maybe. Yeah, so moderate, S2. It looks like moderate would be the thing that we would do there.
I would agree with that. So again, we start looking at, we'll rank it as a moderate, our exposure to the hazard.
Oh, it's going to be every cycle.
So our exposure would be high.
Yeah, for sure.
Again, because that's based on the definition. More than once per day or shift, it's pretty much high.
Yep. Okay. Got it.
And then your chances of avoidance. How fast is your machine moving? Is it moving faster than 250 millimeters?
Potentially it could. Potentially, if we're trying to make, yeah, for sure. So
chances are it's probably not likely.
Right. We can't avoid it. Yeah, that's correct. Yeah, that's right.
So again, once you see that, you can see it starts driving us down through our risk assessment. And once we get over here, there's a correlation. Once you look at the standards, they actually do it automatically for you in the software. It will tell you what kind of performance level you need to meet or above with your hardware and your safety circuit design. So again, that's all per the standards. That's not up to your interpretation. Again.
Okay. All right.
And depending on how you come through this matrix, like I said, more than likely you're going to be down here at a high type scenario anyway.
Okay. All right.
When you get down to the very high, that's where you're going to probably get into more your performance level E type safety systems.
All right.
So now that we've kind of evaluated our machine with no guards in place, or what we're proposing, which is what Henry's got drawn up here, I think we want to kind of discuss on how we want to solve the problem, because obviously that's not a tolerable risk, what we kind of developed there. So your opportunity for protective measures, if we look at the standards, is basically we can design it out.
Right, which is probably the most desirable way to do it, right?
That is definitely the most desirable way. Again, if we could do that, chances are we probably can't do that.
Okay.
Just because the operator's going to have to interface and we've got moving components there. So really kind of where we play a lot of times is in the engineering controls. That's where you're going to start looking at light curtains, putting guards on it, and things of that nature.
Okay.
So, and then down here, your least preferred is going to be your administrative controls.
Training,
PPE.
Okay.
Again,
right,
all acceptable, but from a most preferred to the least preferred, that's kind of how those are going to rank.
And I see it kind of wraps around. So even after you apply the control, then you need to go and reevaluate the risk. And if you didn't derate it enough or make it safe enough, you go back and apply it again.
That's correct.
Okay. All right.
So again, if we jump back to our software here, again, our inherent safe by design, that would be basically if we're going to design it out, our engineering controls, which is what type of solution we're proposing, would be putting some type of guarding on it or either light curtains. So we're going to do light curtains.
Gotcha. Okay.
So we're going to look at doing some access detection, interlocking, or presence sensing safety devices. So again, a light curtain is a presence sensing safety device.
So it gives us a bunch of selections there. You got trap key, two-hand control, operating mode, speed mode. Okay. Yeah, it sounds like it's appropriate.
So then, like I said, it will move the device over there, what we're going to put in place. If we have a required performance level, basically our system's saying we got to meet a performance D or an E.
Okay.
I'm going to pick D just because it's going to be the most complex system. I don't want to put anything more than I have to put on the system.
Gotcha. Okay.
But once we get into the SISTEMA portion, it will validate that we meet that performance level.
Okay.
So now that we've posed our light curtain solution for your moving slide or conveyor, let's kind of reevaluate our situation.
Okay.
So chances of severity of the injury, moderate. The operator he's still going to encounter that. If he still were to get his hand in there, it's still going to be a moderate hazard. That's not going to change.
Right, right.
So when we start looking at our exposure to the hazard, this is where we have the choice of prevented. Basically, we've eliminated the machine from moving if he is standing in that position.
So if he blocks that light curtain when he's loading that plate, there's no way that conveyor can move.
There's no way he can move.
Okay. All right. Good. So I would say that would be prevented.
Yep. And that's what the job of our safety processor. It's going to do that logic, monitoring, and all that for us.
All right.
Basically. So again, you can see how this changed our matrix now to the low tolerable risk level. So again, that's an acceptable level of risk. So I would call this good once we did this.
Okay. Awesome.
And then we'll do
Oh, we got to go do the same thing for the brush. Okay, gotcha.
Like I told you, it's not a hard process. It's just a time-consuming
time
process
consuming.
to
Gotcha.
document all the hazards.
All
That's
right.
where the software can kind of help you do that.
Okay.
Walk you through that, make it a little easier. So again, if your hand or my hand gets tangled in that brush, I'm going to consider it a moderate hazard.
Your hand.
I prefer your hand though.
Okay. Is that how that's going to work? All right.
So, that's right. Exposure to the hazard.
High.
Again,
Definitely high.
Chances of avoidance, not likely.
Not likely.
And again, like I said, even the not possible, you can see it doesn't change our outcome there when we're looking at it. But either one of these choices is really based on the standard when you start looking at those definitions.
Okay. All right.
So either one's going to drive us to a performance level D type system. So we want to add our protective measures. We're going to use that same light curtain.
Oh, so you can reuse the same device then for two different hazards if it applies, if it would
You
protect
can.
from both
You
hazards. Okay, interesting.
So again, it'll be down here under engineering controls. Now it will list it separately in a process.
Yeah, because it's a separate hazard.
But
sure,
you'll see at the
sure.
end, we'll bring it back around and we'll tie those together.
Okay, all right.
Again, so we ranked it high. Now that we've added our light curtain on there, we'll go back through and reevaluate it. Again, we're just going to change the time that somebody interfaces with it.
Yeah.
So we've prevented his access to it.
Okay.
Again, your avoidance of the hazard, not likely. It's going to stay the same.
Gotcha.
All right. So once we've kind of done that portion of the software, again, now it's going to walk us through to the next step, define the span of control. So this is where we're going to start looking at our actual components that we're using
Okay.
and define that portion. How we're going to do that. Basically, how we're going to do the access detection. What's our...
So presence sensing is what we're going to use, potentially a light curtain or something along those lines. So now we go and select the input.
So again,
Presence
because
sensing.
we picked that initial choice, it's limited us down. We've got a presence sensing devices, interlock devices, or guard locking devices. A light curtain is going to be a presence sensing, so we'll pick it. For our logic, just because I like you, I'm going to allow you to use a safety controller. If it was me, I'd prefer a safety relay. And then on
Safety controller, I tell you what, let me tell you something about a safety controller. Number one, they don't cost any more money than a standard controller. Did you know that? You can buy our 5069 safety controller, or you can buy our 5069 standard controller, and they're the same price. Right? So that's why we're going to use a programmable controller.
All right, I'll cave, Hayden. I'll let you use a safety
All
controller.
right, sounds good.
That's a good reason to use
I had
one.
to step out of character, by the way. I guess you guys figured that out. Anyway.
All right. So again, we were going to use the programmable safety controller for an output device on our slide that we're talking about, because we're looking at our first hazard was going to be servo driven. So will you pick a servo drive here? And again, that information we uploaded or filled in before, it starts populating for us, giving us more clues. We're doing it. So that was our first one, and then we got our second. We'll look at here from our brush. So again, we're going to use that same light curtain, presence sensing device. Logic, we'll use that programmable safety controller, and then the output, we'll use an AC drive that's going to run our brush. So we'll save that information. Again, we've uploaded our output devices. We've got our input devices kind of specified a little bit here. So we'll move on to the next step.
Last step, Kevin.
Last step.
We're getting through it.
So again, we will need to specify the actual particular devices, and the reason for that is I mentioned SISTEMA takes into account the mean time to dangerous failure. So some of these components, depending on what you're using exactly, have different mean time to dangerous failures. So that starts designating this information for you.
Okay. All right.
You'll notice here, because we've said presence sensing devices, they've automatically filtered down what all the presence sensing devices are.
So you
see
got point of operational control and then perimeter access control.
looking at the, the light curtains themselves, the point of operation control, we're going to look at a point of operation control because that's something we're going to use right at the hazard point. A PAC is going to be more of a perimeter access, where I'm using that as a virtual fence.
Okay.
So,
all right. So that's the difference between the two.
Yep.
Okay.
Typically, a PAC type light curtain only has a 3-beam type solution or 2-beam, whereas your point of operation control is going to get you that 14 millimeter or 30 millimeter resolution and be a lot more expensive curtain.
So I'll have a beam every 14 or 30 millimeters.
So,
Kevin, that looks like a lot of part numbers. Help me out here. How am I supposed to know which one is which?
yeah, so this is just a list of all the Rockwell light curtains, the 450L series, because that's what we want to use, the newest SIP safety light curtain for your solution. And the difference between these, it's not as bad as it looks. Basically, they've got these designated in our 14 millimeter resolution offerings and our 30 millimeter resolution offerings, and then the length of the curtain itself, so a protected height. For your machine, I think we can get by with the smallest one and a 30 millimeter resolution option. So we'll do the 150 millimeter light curtain here.
With 14, so we can't get our fingers in there. Okay, I see.
Correct. You could get your
With
fingers
the 30,
in,
you could get your fingers in there. With the 14, you couldn't. Okay,
right.
understand.
So, again, mentioned that we're going to do the SIP safety light curtain. So I'll change my connection. So instead of redundant wiring, we're going to do it safety over Ethernet.
Ah, so the connection's like how you actually hook it to the controller. Gotcha. All right.
And you'll notice it also gives me a guard link option, because we have the option to put those on guard link as well. So, and then we're going to designate our controller. I think we'll use a Compact Logics for this. Because we've got motion on it, we'll need to pick a motion controller. And then also, we're just trying to meet a performance level D. So I think that first choice up there would be a good fit for us. And then on our output, we're going to pick basically what servo we're going to use. And for your application, we're going to use a Kinetics 5500.
Okay.
Now you'll notice when I pick the Kinetics 5500, because there's some more information that we got to fill in to designate a part number for the product, this opens up an editor.
So we're generating part numbers here at this point.
You're generating
as a part of doing the risk assessment.
That's correct.
Okay.
And it basically just opens up the product configurator that's, if you're familiar with it online for Rockwell or Proposal Works windows that you see, or in Integrated Architecture Builder, the same editor that you've seen there. So we're just going to put in some basic information about it. We're using a single phase, smallest Kinetics drive that we can. And then, again, we'll designate safety over Ethernet. Again, it's calling out an output module, saying I forgot that.
What is up with that, Kev?
It's because I haven't designated that it's going to be over Ethernet yet.
Ah, and then it disappears, so I don't have to worry about the electrical.
So we're not going to sell you any input or output modules for this, Hayden.
Hey, I don't like that. That's no good. So I think we need to go back to hardwired connections here.
So we've done it for our first, now we'll do it for our brush.
Same process pretty much?
Same process, but because we're using the same light curtain, I can just pick it from down here.
Ooh.
And then we'll get over here to the controller. Oh, I didn't take one. I missed one. So we picked our controller already.
Yep.
And then on our output, I'm going to add a new device. So we already designated we're using a drive, so it brings up my PowerFlex drives. And on your particular machine, we just happen to have a 27.
All right. All right, cool.
So again, we'll have to do the configuration of it.
So the 527 is our motion drive. It's still a PowerFlex drive. It's not a Kinetics drive, but you control that drive with motion instructions, right? In fact, you have to have a motion controller, motion capable controller, in order to control the 527. The other reason that we're using the 527 is because I can do safety over Ethernet, SIP safety. Once again, I don't get to sell any I/O modules, but that's cool because I don't have to do any safety wiring. So that is why we use the 527. No hard wiring for safety. The control is done not only via the Ethernet cable to actually control the drive, but it actually makes it safe too, using SIP safety.
So once we've kind of documented everything, Hayden, we're done now. So
nice.
Now I've saved my project. I can generate the documentation. So I can pick what
Ooh,
documentation.
SISTEMA. All right, so what, I can take that report and bring it directly into SISTEMA?
You'll see.
Imagine that.
That's right.
Does it take a long time to do this?
Not usually.
Not usually. Okay.
Not unless you got 30
We'll
people
say.
staring at you.
It's doing it. It's just doing it. It's got an extra load on it. No, well, there are some things that we do, I think, within the SISTEMA import.
Yeah, this
can
doesn't
take
take long. The SISTEMA import takes a minute or two. So we start looking at, we can export our drawing then, where we kind of labeled our hazards on it. But really, like I said, a couple different options from that picture standpoint where we documented. But where it really starts getting powerful is when we start looking at these, the documentation it builds for us. So again, we've documented here basically our Excel file of our risk assessment, our risk estimate, span of control, and then also our safety functions. So again, the more stuff we had documented from a hazard standpoint, this list would be a lot longer, a lot more comprehensive.
For sure.
So
if we went through and did the entire machine.
If we did the entire machine. It also, you'll see, we can look at, it generates a safety specification requirement for us. So a lot of the documentation that you can edit and do what you want to with it for your facility, certain standards. It defines all the safety functions.
So you would include this with like the SISTEMA report. If you were a machine builder or something like this, you could include this. Or is this just kind of like SISTEMA would be all you'd need, or would you really, I guess you'd want this because this walked you through the process.
Yeah, this walked you through the process. To me, this is probably a more easy to read document from that standpoint. When you're looking at it, the SISTEMA report, like I said, is a lot more detailed and more granular.
Gotcha. Okay.
So we'll look at the SISTEMA portion now.
So is this like an EDS file or something along those lines for each device? Do I have to upload it for each device, or no? Apparently I don't. Okay. So that one file is going to cover me for all the safety devices that Rockwell actually has. Okay.
That's
cool.
correct. So every safety device Rockwell's published, they have this documentation already uploaded into it. Again, that information that it's going to start calculating from your diagnostic coverage, your mean time to dangerous failure, is all uploaded for those particular devices.
So one file. Okay.
That's the reason when we're doing the safety automation builder, we're driving down and specifying the particular device that we're looking at. So because if you actually encounter a product that maybe they didn't upload into it, which I have found some of those,
Right.
it will give you an error when we went back and opened up SISTEMA. Basically, this is our SISTEMA safety project right here, and it's giving us this green check mark saying that we meet all the required performance levels that we said it should meet.
Nice.
Based on what we defined in there. If we didn't meet it for some reason, it would give us a red X right here. So again, and then you can drive down and look at whether it's on a particular safety function that it didn't meet it, where it's at, and you can see what that error is when you start looking at it. It was actually a separate project that just happened to be open as well that I had previously. So this is the one we just create right now. But again, like I said, we start looking at these particular safety functions and all the documentation that's associated with it. Like I said, looking through it, we start looking at our required performance levels, documentation. Again, really when you start diving down into the component level. And again, that's a 10-page report on no more than we did for our safety machine. If you start doing a whole lot, it gives you a whole lot more. And it's all the way down to the device level.
Nice.
So, all right.
That's it?
That's it.
Our risk assessment is done?
Yeah, well, it's not done, but you've seen on the points we've done.
We can probably do a risk assessment is what I'm thinking. So let me ask you though, I think I've heard so if I get my controls engineer and my mechanical engineer, all those guys together, they can sit down and actually do the risk assessment maybe before the machine's designed and put together if they're using like a digital twin or something like that. is that all that really needs to be involved, or?
Yeah, and definitely when you do the risk assessment portion, they recommend it being a team-based approach, and the standards actually kind of recommend that or call that out. Not just your controls engineer that's working on the machine. Try to get multiple people involved, maybe someone from the front office, administrative level.
HR maybe?
HR, someone that's not likely working on that machine, just so that they're not likely to overlook a hazard or something like that they see.
Okay.
More to question it. The other reason is you don't want that sole responsibility on your shoulders.
For dang sure, for dang sure.
You want more people involved. And like I said, the more people, more diverse the group, the better.
Okay. Awesome, awesome.